हेलो फ्रेंड्स, नमस्कार। क्लास 11 चैप्टर 5 लॉज ऑफ मोशन के एक और सेशन में आप सबका स्वागत है। आज हम डिस्कस करेंगे कॉमन फोर्सेस इन मैकेनिक्स। कॉमन फोर्सेस कौन कौन से हमें देखने को मिलते हैं। पहला फोर्स है ग्रेविटेशनल फोर्स, ठीक है, जिसके बारे में हमने बहुत सारा डिस्कस कर लिया है पहले चैप्टर में, ठीक है। बहुत सारी जगह पर होता है और कॉमनली जो हम यहाँ पर यूज करेंगे ग्रेविटेशनल फोर्स, उसमें हम वेट में यूज करेंगे। वेट W इज इक्वल्स टू mg होता है ना। कोई भी ऑब्जेक्ट होता है, ठीक है, तो उसको वेट उसके सेंटर ऑफ मास पे नीचे लगता है, ठीक है। तो पहला जो है वो वेट। सेकंड वन इज द कांटेक्ट फोर्स। कांटेक्ट फोर्स, ये जो ग्रेविटेशनल फोर्स है ना बच्चों, ये फील्ड फोर्स है। कैसा फोर्स है? फील्ड फोर्स है, ठीक है। मतलब ऐसा नहीं कि ये ग्रेविटेशनल फोर्स किसी दो बॉडी अगर कांटेक्ट में आएगी तब भी दो बॉडी के बीच में ग्रेविटेशनल फोर्स लगेगा, नहीं। वो तो एक दूसरे के फील्ड में आती है, फिर भी ये ग्रेविटेशनल फोर्स लगता है। अभी कांटेक्ट फोर्स का मतलब क्या है कि ये फोर्स तभी लगता है, फोर्स अराइजेस बिकॉज ऑफ कांटेक्ट बिटवीन टू बॉडीज। ओके, व्हेन टू बॉडीज आर इन कांटेक्ट विथ ईच अदर, then the force resulted is known as the contact force. Contact force is of two types. One is a normal reaction and one is a friction. Normal reaction is denoted by capital N and friction is denoted by small f. Okay, suppose there is a surface, okay, and body is placed on it. Okay, so body is in contact with the surface. Okay, so because of that the surface will apply two types of force on the body. Why? Because body is in contact. Okay, one force perpendicular to the surface, perpendicular to surface. Okay, listen carefully. If body is like this, okay, and here if you are placing two objects, then here perpendicular means like this, perpendicular means like this, perpendicular to the surface. Okay, and one is the parallel to the surface. Another force is the parallel to the surface. One is the perpendicular to the surface and another is the parallel to the surface. Remember carefully. This perpendicular to the surface is nothing but N. What is that? N. That is the normal reaction. And parallel to the surface is nothing but the friction, which we are going to discuss in detail in the coming sections. Okay. Friction. It is acting parallel to the surface, and when friction will act when two bodies start sliding on each other. Start sliding on each other. Okay, is that clear to you? Okay, so these forces, normal force and friction force. Normal force is acting perpendicular to the surface and friction force is acting parallel to the surface. Okay, is that clear to you? One thing is that suppose there is a body, okay, and you are holding the body like this. Okay, clear to you? Then this surface will exert normal reaction on this side. Okay, and friction, it can be on this side or it can be on this side. Okay, that we will discuss that on which side it will be. Okay, if body want to slide on this side, then friction will be here. And if body want to slide on this side, upper side, then friction will be in the opposite direction. Okay, is that clear to you? Okay, so what we got? Normal reaction is a perpendicular to the surface. Okay, always. Like what? Suppose the surface is like this and you are placing object here. And where the normal reaction will act? Here. Clear to you? Okay. And where the friction will act? Here. Either here or here. Clear? Okay. And provided that surface is smooth, then friction will be zero and only normal reaction will be there. Is that clear? Okay. So that is the contact force. Now let's discuss a tension. That also we have discussed somewhat in the previous session, that if some object, okay, is suspended with the help of string, okay, then you will find a tension. If you see from here, then tension will seems to be in upward direction, and if you see from here, tension will be seems to be downward. Okay, remember, tension is always in direction of string. Direction of string in the sense, if you see from here, then you see that string is going upward, right? That's why tension is here. And if you see here, then tension like this. Suppose if you think, sorry, suppose if you think that two objects are like this. Okay, one object is here and there is a string between them and another object. Okay, and you are pulling here. Then this object number one, will experience tension in this direction. Means this object one is under two forces. One is a force which is in this direction and another tension which is in this direction. Okay, and here this object number two will experience tension in this direction. Okay, it is under experience of the one force only, tension. Okay, and the tension will be is equals to ma, means mass into acceleration, net force. Okay, you will say yes, it is under action of mg and n, but mg and n will cancel each other. Why? Because it is sliding, not jumping. Clear? If it is jumping, then we can say either n or mg may get increased. Is it clear to you? Okay, so wherever there is a string occurs, string or rope, string or a rope, okay, at that time you have to consider this force. Which force? Tension one. Okay, and now the last one that I want to discuss today is the force due to spring. That is, suppose this is a spring. Oh, sorry, today's session is somewhat theoretical session. Okay, today we are not going to solve any example. Small session, theoretical session. Suppose this is a spring. Okay, relax the spring. What you can say? Relax the spring. Okay, and this is a body of mass m. Okay, so here it will not experience any force, this body. Oh, sorry, it will not exert any force on the block. Okay, but suppose if you move block on either side, either on this side or on this side, then what happens? See, then if you move block on this side, side number 1, okay, direction, then spring will get extended. So because spring get extended, spring want to be in the relaxed state. So this spring will exert force on the block in this direction, and it is called a restoring force. What is that? Restoring force. Is it clear to you? Okay. And suppose you move block on this side. Okay, then again spring will apply this type of force. I think you have experienced this force also in common experience, that if you compress the spring, spring will compress you. If you pull the spring, spring will pull you. It is nothing but, again, what is that? Restoring force. Spring always want to be in the relaxed situation. So if suppose like this also, this is a suppose relaxed situation, but if you hang something, then what happen? Spring will get extend, and because the spring get extend, it will apply restoring force in the upward direction on the block. Means what? You can consider here mg and here this restoring force. Is it clear to you? And here what you can say, that here somewhat applied force on this side and here restoring force, like that. So this is the case when spring is there. So whenever there is a spring, then at that time you have to see the situation, that is spring is compressing, expanding, what is there. So according to that you have to apply the force. Okay, and that is nothing but the restoring force. This force also we are going to discuss in detail in the case of the chapter oscillation. Okay, so today we have discussed force due to spring, then after tension, then after contact force. Contact force is of the, okay, one force we have not discussed, this one, buoyant force. Okay, let me discuss it. Okay, suppose this is a liquid or suppose fluid, and you immerse some object in it, then what happen? it will experience buoyant force in the upward direction. Okay, is it clear to you? It will experience buoyant force in the upward direction, and this buoyant force will be equals to weight of displaced liquid, displaced liquid or fluid. Right now we are in the air, means we are displacing some air. So air is also exerting buoyant force on us, but because weight of that displaced air that we have displaced, okay, that is very small, that's why we are not experiencing. But if we jump in the swimming pool and some other you can say river or pond, okay, at that time we are displacing the liquid whose density is more. That's why the displaced liquid's weight will also be more, and at that time we can experience some notable buoyant force. Okay, our weight will get decreased. So that is nothing but the buoyant force. That also we are going to discuss in the fluid mechanics. Okay, is it clear to you? Right now in this chapter, this contact force, this tension and friction, and a gravitational force, okay, that will be get discussed. Okay, is that clear to you? Okay, so in this session we are going to discuss only this much. We have discussed only this much, and in the next session we will solve some interesting examples or a free body diagram also. Okay, is that clear to you? Okay, fine. So we will meet in the next lecture. Thank you and namaskar.